Hi guys. Today we're going to be working on not section 5.4, but section 5.5, and this is called multiple angles formulas. Similar to the sum and difference formulas that we learned about, we are going to just be using these formulas to help us solve as well as simplify some different types of equations. So as you can see, sine of 2x is equal to 2 sine x cos x. Cosine 2 theta has 3 options that it can be equal to, so depending on the scenario, we'll choose the most appropriate. And tangent 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta. Let's get started with the first one. It says, using the sum and difference formulas, solve. All right, let's go ahead and do that. So cosine 2 theta. When you think about which one you want to use here, we're solving. So cosine has multiple options here, but I noticed I already have a cosine here, so I'm going to choose to make everything in terms of cosine for this problem. So I'm going to replace cosine 2 theta with 2 cosine squared theta minus 1. And we've got that plus cosine theta on the end equals 0. Alrighty, so now I can rearrange this to be 2 cosine squared theta plus cosine theta minus 1 equals 0. And we can go ahead and factor this up, and you will get 2 cosine theta minus 1 times cosine theta plus 1 equals 0. Let's set each factor equal to 0. Cosine theta equals 1/2, and over here, we're going to get cosine theta equals -1. All right, so we can look at the unit circle and see where these things exist. So for cosine theta equaling 1/2, we have that occurring at pi over 3 as well as 5 pi over 3. And since there's no interval, we're going to add the 2 pi n on the end. And where cosine theta equals -1, that's going to be at pi, and then we're adding every 2 pi n. Or you could start off at 0 and add 2 pi n. So I think I would even just write 2 pi n for that one. So there's our solutions for that first problem. The second problem is 4 sine theta cosine theta plus 1. Now, upon first glance, there's not even a double angle formula here, but there's no identity that I know already to help me solve this. So I know this looks kind of similar to a double angle formula that we have. And I'm going to just pull a 2 out in front. And then I have 2 sine theta cos theta plus 1 equals 0. And 2 sine theta cos theta is equal to 2 sine x. So I've got 2 times sine 2x, or 2 theta we're using, sorry, plus 1 equals 0. All right, let's get that sine 2 theta alone. Sine 2 theta equals -1/2. And remember, we've worked on these before. So where does regular old theta equal -1/2? Okay, well, regular theta equals -1/2 at 7 pi over 6, as well as 11 pi over 6. There's no interval to solve on, so I'm going to add all solutions to pi n. But remember, we are not solving for just a regular theta. We have a 2 theta in front. So to get rid of that 2 theta, we have to multiply by 1/2 everywhere. So what's our final answer? Our final answer here is going to be theta equals 7 pi over 12 plus pi n, as well as 11 pi over 12 plus pi n. And last but not least, down here it tells you how do we use these formulas for any triangle? Well, we definitely can do that. But we're going to change this problem. It's just kind of missing some elements here. we're going to say cosine u actually, equals -2/7. And you also need the given information about what quadrant this triangle's located in. This is saying it's between pi/2 and pi, which means this triangle is in quadrant 2. Okay, so let's go ahead and draw this up in quadrant 2. We've got adjacent side over the hypotenuse, okay? And let's go ahead and solve for the missing side. We're going to get -2 squared plus y squared equals 49, 7 squared. And we get y squared equals 49 minus 4 is 45. And so y equals the square root of 45, which we can also, if we would like to, that's 9 times 5. So that's going to be 3√5 as our other missing side. All right, sine 2 theta. Let's go ahead and look at our formula. Sine 2 theta is equal to 2 sine theta cosine theta. So let's find out what that is. 2 sine theta is going to be opposite over hypotenuse, 3√5/7. Times cosine theta is already given, -2/7. So 2 times 3 times 2 is 4 times 3 is -12√5/49. So there's our sine 2 theta. Let's find cosine 2 theta. You can pick any formula that you would like. Since we're given cosine, I'm going to use 2 cosine squared theta minus 1. So 2 times that cosine squared is going to be -2/7 squared minus 1. This is going to be 2 times 4/49 minus, I'm going to make this 49/49. 2 times 49 is 8 minus, or 2 times 4 is 8 minus 49/49. And 8 minus 49 is going to be a -41/49. There's our cosine value. And last but not least, let's find our tangent 2 theta value. So that formula is 2 tangent 2 theta all over 1 minus tangent squared theta. All right, so 2 tangent of theta is opposite 3√5 over adjacent, which is -2. And that's divided by 1 minus 3√5/2, -2 squared. All right, let's deal with this. So these cancel out, and in the numerator, I'm left behind with -3√5 over, let's work with the denominator. 3 times 3 is 9. 9 times 5 is 45. So that's going to be 45 here. All over -2 times -2 is 4. And let's make that one 4/4. So we've got -3√5, and 4 minus 45 is 41/4. -3√5/1 times the reciprocal, 4/41, is -12√5/41. Actually, I'm sorry because we have a double negative right here that I accidentally messed up. This is -41, so that's going to be actually a positive 12√5/41. So you're going to use these formulas on your homework to help you verify, solve, and work with those formulas just like we did with the sum and difference formulas. All right, so that was multiple angles formula. You can start working on homework number 7. Bye.